Let us start today's chapter with chapter 13, unit 1, statistical representation of data. So, statistical description of data, unit 1. So basically, here's an overview of the unit, entire unit. So application of statistics. So first is the collection of data, which is of two types: primary data or secondary data, which is collected from other sources. Presentation data in textual and tabular form, that is frequency distribution and cumulative frequency. Then we have present data graphically. We have line chart or histogram, pie chart, frequency, polygon. Okay, let us move further to the introduction of statistics. The modern development in the field of not only management, commerce, economics, social sciences, mathematics and so on, but also in our life like public services, defense, banking, insurance sector, tourism and hospitality, police and military, etc. are dependent on a particular subject known as statistics. Statistics, okay, all these things, basically history is written, then definitions are written, that science of counting, science of averages, no need to go through in the depth. Okay, then we have application of statistics. We have certain use in the fields of economics, business management, commerce and industry. Economics, modern developments in economics have the roots in statistics, like economics and statistics are closely associated. Time series analysis, index numbers, demand analysis are some overlapping areas of economics and of statistics. Okay, now in this connection we may also mention that econometrics, it's a branch of economics that interact with statistics in a very positive way. Okay, then we have business management, then we have statistics in commerce and industry. Then we have limitations of statistics, that is it deals with aggregate and individual to a satisfaction. Statistician has no significance except the fact that it is a part of the aggregate. Statistics is concerned with quantitative data. However, qualitative data can also be converted to quantitative data, but by providing numerical description to the corresponding qualitative data. Future projections of sales, production, price and quantity, etc. are possible under a specific set of conditions. If any of these conditions are violated, projections are likely to be inaccurate. Okay, now the theory of statistical inferences is built upon random sampling. If the rules for random sampling is not strictly adhered to, the conclusion drawn on the basis of these unrepresentative samples would be erroneous, means it would be not accurate. Okay, in other words, the experts should be consulted before deciding the sampling scheme. Now we have collection of data. Firstly, before moving further, let us understand what does the meaning of all these things, history and all those things had. So first of all, Chanakya or Kautilya wrote Arthashastra. In the medieval period, Akbar reigned 16th century AD. Ain-e Akbari was written by Abu Fazl. Then Egypt, first census was conducted by Pharaoh between 300 BC to 2000 BC. Now in Latin it is known as status, Italian it is known as statista, French it is known as statistique, German it is known as statistic. Now we have two types of statistics: descriptive statistics and inferential statistics. Descriptive, summarizing and describing the features of a data set. Inferential, using a sample of data to make predictions or inferences about a larger population. Definition: singular sense, it is a method of science, that is collection, organization, presentation, assembling or analyzing and interpreting. Then plural sense, it is qualitative, quantitative. Quantitative, it is descriptive or continuous, and then it is just aggregate of facts. Okay, apart from that, we have scrutiny of data, which is known as verification, which should be accurate and consistent. Okay, then we have types, that is primary data, secondary data. We will be moving further, but let us see over here. We may define data as a quantitative information about some particular characteristics under consideration, although a distinction can be made between a qualitative characteristic and a quantitative characteristic. But so far as the statistical analysis of the characteristic is concerned, we need to convert qualitative information to quantitative information. All these things are there. Primary and secondary are there. Collection of primary data. Now here you can see, collection of primary data by interview method. Direct interview is best for natural calamity. Indirect interview best for train accident. Telephonic interview it is the fastest method. Okay. Then we have questionnaire method, which has two things: mailed questionnaire method and enumerator method. Okay. Then we have observation method, that is seeing and listening. Then we have secondary data, and it is basically from other sources like international sources, government sources, private and semi-private and unpublished sources. Let us move forward towards the classification of data, that is temporal, chronological means date wise, spatial, geographical, Qualitative means nominal or ordinal. Nominal means no rank and ordinal means ranking based, and quantitative means cardinal basically. Okay, now we have some essentials for a good classification, but let us see the book first. Okay, so these were the collection of primary data. Then we have sources of secondary data, international sources like WHO, ILO, IMF, World Bank, then government sources, statistical abstract by CSO, then Indian Agricultural Statistic by Ministry of Food and Agriculture, private and quasi-government sources, ISI, ICAR, NCERT, and published sources of various research institutes, researchers. Now we have scrutiny of data. That is what I said, verification. Now, since the statistical analysis are made only on the basis of data, it is necessary to check whether the data under consideration are accurate as well as consistent. No hard and fast rules can be recommended for the scrutiny of data. One must apply his intelligence, patience, and experience while scrutinizing the given information. Errors in data may creep in while writing or copying the answer on the part of the enumerator. A keen observer can easily detect that type of error. Again, there may be two or more series of figures which are in some way or other related to each other. If the data for all the series are provided, they may be checked for internal consistency. As an example, if the data for population area and density for some places are given, then we may verify whether they are internally consistent by examining whether the relation density is equal to population upon area holds. Okay, so apart from that, we have presentation of data, that is classification or organization of data. Okay, it puts the data in a neat, precise and condensed form so that it is easily understood and interpreted. It makes comparison possible between various characteristics if necessary, thereby finding association. Statistical analysis is possible only classified data, eliminates unnecessary details and makes it more reliable. Understanding. Okay, data classification we have already learned. Mode of presentation of data we know over here, which was here. Presentation of data, textual, tabular or diagrammatic. Let's see. So, textual presentation, tabular presentation or tabulation, diagrammatic presentation. Okay, this is the textual presentation and there are some examples are also given. Then tabular presentation in forms of tables are there, and also there are basically five there are basically 5 elements of a table are there. Okay, let us study it. Tabulation may be defined as systematic presentation of data with the help of statistical table having a number of rows and columns and complete with reference number, title, description of rows as well as columns and footnotes if any. A statistical table should be allotted a serial number along with explanatory title. Okay. The table under consideration should be divided into caption, box head, stub and body. Caption is the upper part of the table describing the columns and subcolumns if any. The box head is the entire upper part of the table which includes columns and subcolumn numbers, units of measurement along the caption. Stub is the left part of the table providing the description of the rows. The body is the main part of the table that contains the numerical figures. The table should be well balanced in length and breadth. The data must be arranged in a table in such a way that comparisons between different figures are made possible without much labor and time. Also, the rows, tables, columns, totals, the units of measurement must be shown. The data should be arranged intelligently in a well-balanced sequence, and the presentation of data in the table should be appealing to the eyes as far as practicable. Notes describing the source of the data and bringing clarity and if necessary and about any rows or columns known as footnotes should be shown at the bottom part of the table. Okay, then we have, this is a table. Basically, these are your columns, these are your rows. So basically, the horizontal part is known as rows, the vertical part is known as columns. Okay, now this entire part is the box head. Okay, this one and specifically these, okay, separately are the stub. Okay, then these are the column head. Okay, apart from that we have a footnote is given over here. Okay, and some table like this, table 13.1.1, that is what that is can be said as caption. No, that is not caption. That could be said as number, reference number or title. Okay, apart from that we have some more things, that is diagrammatic representation of data. So diagrammatic representation of data, another alternative and attractive representation of statistical data, is provided by charts, diagrams and pictures. Unlike the first two methods of representation of data, diagrammatic representation can be used for both the educated section and uneducated section. So this point, that diagrammatic representation can be used for both educated section and uneducated section of the society. Furthermore, any hidden trend trend present in the given data can be noticed only in the mode of representation. However, compared to tabulation, this is less accurate. So this is less accurate. So if there is a priority for accuracy, we have to recommend tabulation. If there is a priority for accuracy, if you want accuracy, then we have to recommend tabulation. Now, types of diagrams are there: line diagram, histogram, bar diagram, and pie chart. Now, before knowing that, let us see further over here. Now, we have essential or elements or principles of a good classification. It should be exhaustive. It means that it should include all possible points. It should be mutually exclusive. Avoid overlap and each data one category. It should be unambiguous. It should be clear and precise. It should be stable and flexible, adaptable. It should be homogeneous, same category, character, and consistency. Presentation, I said, textual, tabular, 5 elements, diagrammatic, bar diagram are there. Then vertical bar diagram for quantitative data vary over time, horizontal, qualitative, space it requires, because then third is component bar diagram, that is a stacked bar diagram. This is category based. Okay, multiple bar diagram, it is like complete for 2 or more sets. Okay, then we have line diagram, that is ty plane, it is one dimensional, it is like this one. Pie chart slices categorical data. Then we have ratio chart, that is for log basically. Okay, then after that we have frequency distribution, frequency density ka formula. We have frequency upon class width, relative frequency, frequency upon total frequency, often expressed in decimal or percentage. Graphical representation of a frequency distribution: frequency curve is bell shaped, then U shaped, then J shaped, then mixed curve. Mode can be found by histogram, median can be found by less than or more than ogives. Then we have graphical representation of a frequency distribution. Histogram is a 2D figure, frequency polygon is a one-dimensional figure, cumulative frequency curve is one-dimensional figure, frequency curve is again one-dimensional, cuboid is 3-dimensional, ogive can be used for making short-term projections. Now, keeping this aside, let us study these one by one. Line diagram or histogram. When the data vary over time, we take recourse to line diagram. In simple line diagram, we plot each pair of values of ty, yt representing the time series at the time point t in the ty1 plane. The plotted points are then joined successively by line segments and the resulting chart is known as line diagram. Okay, this can be said as a line diagram. Okay, when the time series exhibit a wide range of fluctuations, when it has a wide range of fluctuations, we may think of logarithmic or ratio chart where log y1 and not y1 is plotted against t. We use multiple line chart for representing 2 or more related time series data expressed in the same unit, and multiple axis chart in the somewhat similar situations in the variables expressed in different units. Okay, bar diagram. There are 2 types of bar diagrams, namely horizontal bar diagram and vertical bar diagram. Now, horizontal bar diagram is like this. Okay, horizontal bar diagram. Vertical bar diagram is like this. Okay, so when we are talking about quantitative, vertical bar diagram is best, while we are talking about horizontal bar diagram, it is basically for like qualitative, you can say qualitative, or you can say spatial or geographical, it is, isn't it? Then while horizontal bar diagram is used for qualitative data, you can see it is written over here, or data varying over space, that is spatial or geographical. The vertical bar diagram is associated with quantitative data or time series data. Yeah, basically bars, that is rectangles of equal width and usually of varying lengths, are drawn either horizontally or vertically. We consider multiple or grouped bar diagram to compare related series. Component or subdivided bar diagrams are applied for representing data divided into number of components. Okay, so component or subdivided bar diagram. Finally, we use divided bar charts or percentage bar diagram for comparing different components of a variable, also the relating components to be whole. For this situation, we may also, okay, now here is an illustration given and you can see how beautiful it has represented the line diagram. Okay, and over here it can be said that it is varying over time. So basically it is what? It is chronological. Okay, then we have profits in lakh rupees. Okay, so that is how it is represented. Again, we have some bar diagram over here. Once again, another example: wheat, rice, production in metrics. So we have made 2 line diagrams. We will be making 2 bar diagrams also. So yeah, 2 bar diagrams. Over here, appropriate diagram for with, okay. So we have revenue in millions. Okay, so first, okay, now, nice. This is a pie chart basically. This is a pie chart showing distribution of revenue. Firstly, we have added all these things. Then, into 360 degree, because the circle is basically 360 degree. And in that degrees, we make the angles basically, okay. So, These are the illustrations. Now over here, frequency distribution. As discussed in the previous section, frequency data occur when we classify statistical data in respect of either a variable or an attribute. Okay, either a variable or an attribute. A frequency distribution may be defined as a tabular representation of statistical data, usually in an ascending order, relating to a measurable characteristic according to individual value or a group of values for the characteristic under study. In case the characteristic under consideration is an attribute, say nationality, then the tabulation is made by allotting the numerical figures to the different classes the attribute may belong alike. In this illustration, counting the number of Indian, British, French, German and so on. The qualitative characteristic is divided into a number of categories of classes which are mutually exclusive and exhaustive. So what is exhaustive? What is exhaustive? It should include all the possible things, and exclusive means non-overlapping. Let us check if I am correct. So that was okay. So exhaustive include all possible points and exclusive means not overlap each category. Okay, nice. So, and the figures against all these classes are recorded. The figure corresponding to a particular class signifying the number of times or how frequently a particular class occurs is known as frequency of the class. So, how frequently a particular class happens, that is frequency of the class. Thus, the number of Indians as found with given data, frequency of Indians. So, frequency distribution statistical table that distributes the total frequency of the number of classes. The tabulation is done with respect of discrete random variable. It is known as discrete or ungrouped or simple frequency distribution. In the case of characteristic under consideration consideration is a continuous variable, such as the classification is termed as grouped frequency distribution. Okay, in case of a grouped frequency distribution, tabulation is done not against a single value as in the case of attribute or discrete random variable, but against a group of values. The distribution of the number of car accident in Delhi during 12 months of this year 2005 is an example of a ungrouped frequency distribution, and the distribution of heights of the students of St. Xavier's College for the year 2004 is an example of a grouped frequency distribution. We have an example. Following are the records of the babies born in a nursing home in Bangalore during a week. B denoting boy and G for girl. Okay, so BG like that. Construct a frequency distribution table. Okay, now we have to manually count these things together. Okay, we have to manually count the gender. Okay, and then write it like in the form of table. You can make it in the form of like graph or any kind of chart, whichever you feel like. Okay, likewise we have made it. Total we have written, then boy 16, girl 14. Nice. Now for the construction of frequency distribution of a variable, we need to go through the following steps. What are the steps we need to focus on while we are making what? While we are making frequency distribution. Okay, nice. So the first and the foremost step, find the largest and the smallest observation and obtain the difference between them, knowing as range in case of continuous variable. Form a number of classes depending on the number of isolated values assumed by a discrete variable. In case of a continuous variable, find the number of class intervals using the relation number of class interval into class length that will be equivalent to range. Okay, present the class or class interval in a table known as frequency distribution table. Apply tally mark. Yeah, tally mark can be applied in a stroke against the occurrence of a particular value of the class. Tally mark is what? Like 1, 2, 3, 4 and then 1 cross. This is counted as 5. Okay. Count the tally mark and present these numbers in the next column known as frequency column. Finally check whether the total of these are frequencies are tally with the total number of observations. So we have an example over here. We have to make frequency distribution of prior printing mistakes. Okay, nice. So let us see. Since x, the printing mistakes is a discrete variable, x can assume 7 values 0, 1, 2, 3, 4, 5 and 6. This we have 7 classes, each class comprising a single value. We have made these printing mistakes, tally marks, frequency, number of pages. Then we have another thing. 36 BBA students of St. Xavier's College. Okay, solution we have range, maximum weight minus minimum weight, that is 29 kg. Now number of class interval into class length, that is equal to range. Okay, nice. Yeah, then we have the class interval, isn't it? We have to make the class interval for 44 to 48. We have made it like 6. Okay, so 44, 45, 46, 47, 48, like 4 gaps we have made. 49, 50, 51, 52, 53, 4 gaps. Okay, nice. So number of class interval are there 6. So 1, 2, 3, 4, 5, 6. So basically what we are doing over here is that we are counting the number of class interval, because number of class interval into class length is equivalent to range. Range is what? 29 kg. So we have made it like that. And if you want to calculate the number of class interval, like you count 1, 2, 3, 4, 5, 6. There are 6 class interval in total. So if you want to calculate the class interval, you divide this range by what? Class length. Class length is what? 5. How could we know that? It is written over here, take class length as 5. So it is very easy. Now, class limit. Corresponding to class interval, the class limits may be defined as the minimum value and the maximum value of the class intervals may contain. The minimum value is known as the lower class interval, lower class limit. The maximum value is known as upper class limit. For the frequency distribution of the students, lower class limit, upper class limit of the first class interval are 44 kgs and 48 kgs. This is the what? This is the lower class interval. This is the upper class interval. Okay, nice. Class boundary. Class boundaries may be defined as the actual class limit of a class interval for overlapping classification or mutually exclusive classification. Now over here, could you say that it is exhaustive or exclusive? This is not mutually exclusive, this is exhaustive. Okay, what is exhaustive basically? What is exhaustive? Let us see once again. Okay, exhaustive means include all possible points. So I think it is exhaustive, because if it is mutually exclusive, it should avoid overlapping of each data. It should be exhaustive and mutually exclusive. Okay, so what it says that mutually exclusive classification that excludes the upper class limits like 10, 20, 20, 30, 30, 40. So it is what? It is not mutually exclusive classification. We can see it, right? Okay, class boundaries coincide with class limits. This is usually done for a continuous variable. However, for non-overlapping or mutually inclusive classification, that includes both the class limits for non-overlapping or mutually inclusive. This is one is mutually inclusive, okay, which is usually applicable for discrete variable. We have lower class boundaries, lower class limit minus d upon 2. Upper class limit is equal to upper class limit plus d upon 2. D is the difference between lower class limit of the next class interval and the upper class limit of the given class interval. For the data presented in the table, this one, like this table, lower class boundary of the first class interval would be what? Lower class limit. What is lower class limit? 44 kg minus D. D is what? Difference between lower class limit of the next class interval and the upper class limit of the given in class interval. Yani ki 48 and 49. Okay, basically 49 minus 48 upon 2. So this is the upper class boundary. And likewise, we have made all the other corresponding upper class boundaries, lower class boundaries, and so on. Now, midpoint or mid value or class marks. So midpoint, mid value, class marks. Simple. Corresponding to a class interval, this may be defined as the total of the two class limits or class boundaries are divided by 2. Basically, it gives an average, you can say. Midpoint, okay. Lower class limit plus upper class limit upon 2. Lower class boundary plus upper class boundary upon 2. Referring to the distribution of the weight we have been given, we made it like, okay, width of size of class interval. The width of a class interval may be defined as the difference between upper class. Okay, so width or size of a class interval. We have the width of a class interval may be defined as the difference between upper class boundary and the lower class boundary, that class interval. For the distribution of weights of BBA students, see the class length or width is 48.5 kg minus 43.5 kg. 5 kg is that, okay, for the first class interval. That is, for the other class intervals also, C remains the same. Cumulative frequency, the cumulative frequency corresponding to a value for a discrete variable or a corresponding to a class boundary for a continuous variable may be defined as the number of observation less than the value or less than or equal to the class boundary. This definition refers to the less than cumulative frequency. We can define more than cumulative frequency in a similar manner. Both types of cumulative frequencies are shown in the table. Okay. Less than cumulative frequency, more than cumulative frequency. How? 43.50, 0 we have wrote. Okay, let's say less than 43.50, no. Less than 48.50, this minus this one. Okay, 48, like 43, 44, okay, I am not getting it. Okay, so we are over here. Let's say 73 and 68, 69, 70, 71, 72, 73. Okay, so 5 basically. Okay, so it's 0 plus 3. Then 3 plus 4 or 7. Why 4? Because 48, 49, 50, 51, 52, 53. Or just simply 49, 50, 51, 52, 53. It's 5 then. Okay, let's see. the frequency density of class,